In this video, I will discuss a JEE Main PYQ from the topic simple harmonic motion. This question is based on potential energy and kinetic energy stored in the system. Let me take a simple system. A block of mass m attached to a spring of spring constant K, and there is a fixed support here, and the folding is lying on a surface, frictionless surface. So this is a relaxed position. So from this relaxed position, this is a positive x direction. I'll stretch it by an amount. Say xm from here to here. I'll pull this block up to this xm and then leave it. So what will happen is this block will start oscillating. So you come here, you have got some velocity, so will go back and then come here. So this thing will keep on continuing. So this is simple harmonic motion. It's an oscillatory motion. So let me consider a particular situation where the block is at a distance x from this initial relaxed position. Say this distance is x. So the block is at a distance x. The potential energy stored in the system is the potential is stored in the spring. So the spring is stretched by a distance amount x. The potential energy stored in the spring is half k x square. And the kinetic of the system is half m p square, where v is the velocity of this block m. Spring is massless, so the kinetic energy stored in this kinetic energy stored in the spring is 0. So the kinetic energy is stored in the mass and the potential energy is stored in the spring. Okay. So this motion is of the form xm. Xm is actually the amplitude of the motion. You can call it xm or also a. Xm is same as a, the amplitude of the motion. So it's a sine omega t plus phi. So from this we get the velocity, which is dx by dt as a cos omega t plus phi, and is differentiated with respect to time. So if I differentiate this omega t, I'll get omega. So velocity as a function of time is known. For each point in the motion, time is changing and also x is changing. So can we eliminate this time in terms of x? So this can be written as a omega, and cos is nothing but square root of 1 minus sine square, because sine square plus cos square is 1. So this cos I can write as 1 minus sine square, and sine is x by a. So x by a whole square. Cos is square root of 1 minus sine square, and sine I can get from here. So here I got the velocity in terms of x. This is velocity in terms of time. Instead of time, I can have the variable as x. So this can be rewritten as omega into square root of a square minus x square. So this motion, it starts from here. The velocity will keep on increasing because here the force is towards the mean position. So velocity will be maximum here. After that, when it comes here, the force will be towards the mean position. So it will be opposing the motion. So the velocity will keep on decreasing. So velocity is 0 here, maximum here. Again keep on decreasing. So velocity is 0 here again, and maximum here, like this. So kinetic is maximum at this middle point. So if you put x equal to 0, velocity is maximum. So kinetic is maximum. But the potential energy is minimum at the mean position, maximum at the extreme position. So the sum of the energy, total energy, which is potential energy plus kinetic energy, that should be constant because there is no other form of energy and total energy is conserved. So half k square plus half, okay, kinetic energy, we have to get the expression. So half m v square is from here. So omega square into a square minus x square. So we add these two, and also for simple harmonic motion, this condition is there that k equal to m omega square. This should be satisfied. What is the motion be in SHM? So k and m omega square are same. So if I add these two, this term will cancel. So the potential will become half m omega square a square, which is a constant. It's not dependent on x or time. So total energy is constant. So with this understanding, you can solve this JEE Main question. So this is the question. A particle is executing simple harmonic motion, SHM. The ratio of potential energy and kinetic energy of the particle when its displacement is half of its amplitude will be. You can pause and run this question. So potential energy U, it's half k x square, and kinetic energy half m v square, half m v is omega into square root of v square minus x square. For a circular motion, we know that omega is velocity is omega into r. So it should match dimensionally this one. So it's omega into some distance, which is a square minus x square. So this is radians per second, and this is meter. So it will be meter per second. So dimension is correct. So velocity square will become omega square into v square minus x square. And for SHM, k equal to m omega square. So to find the ratio, u by k. So k and m omega square will cancel. Half will also cancel. So it's x square by a square minus x square. So we have to find the ratio when the displacement is half the amplitude. So x is a by 2. So this will become 1 by 4 a square by 2 square. So a square will cancel. So just 1 by 4. 1 minus 1 by 4. X is a by 2. So a square by 4, a square will go. So just 1 by 4 will remain. So this is 1 by 4 by 3 by 4. So this is 1 by 3. So ratio is 1:3. So option B is the correct answer. This is a very simple question. Just that you have to know this potential is half k x square and kinetic energy is half m v square, and v is in terms of x is omega into a square minus x square. And one more thing you have to know is for a SHM, k equal to m omega square. That condition should be satisfied. B is the correct answer. So this is what I explained here. Potential energy is half k x square and kinetic is half m v square, and velocity is omega into square root of a square minus k. It's of the form v equal to omega into r for a circular motion. So instead of r, we have something of the units of distance, which is a square minus x square. So from this, kinetic is half m omega square a square minus x square, and for an SHM, this relation is valid, k equal to m omega square. So the ratio These two will cancel, half will cancel. Okay, and this ratio at A by 2. You have to find the ratio when the displacement is half the amplitude. It's 1 by 2.